This is a video on how to solve homogeneous differential equations. The question is to solve y prime is equal to x squared plus y squared over 2xy. So we look at the differential equation and we notice that x squared is of degree 2, y squared is of degree 2, and 2xy is of degree 2 because we get one from the x and one from the y. So each term is of degree 2. In particular, when every term is of the same degree, then we say that it's a homogeneous differential equation. So in that case, a method is to let y equal xv. It's going to be a substitution. And when we do that, when we take a derivative, we use a product rule. So we have y prime is equal to x times the derivative of v, or v prime, plus the derivative of x, which is 1, times v. So now we substitute. The y prime becomes xv prime plus v. The x squared stays the same. And then y squared becomes xv quantity squared. And then the 2xy becomes 2x times xv. Now it's time to do a bit of algebra. We notice that xv quantity squared is x squared v squared. So what we can do is we can pull out the x squared in this numerator, and we have x squared times 1 plus v squared. The denominator, we can put the x's together and we get 2x squared v. We can cancel the x squareds and we get 1 plus v squared over 2v. So the next step is to take this plus v and subtract v from both sides to get rid of the plus v. So I subtract v, and then I'm subtracting fractions, so I put it under common denominator 2v. v times 2v is 2v squared, and then over 2v. And 1 plus v squared minus 2v squared is 1 minus v squared. So we finally get xv prime is equal to 1 minus v squared over 2v. Or in other words, x times dv dx equals 1 minus v squared over 2v. Now we have a separable differential equation. So we can separate the variables. That means put the x's on the right and the v's on the left. So I'm going to divide by x and multiply by dx to get 1 over x dx on the right-hand side. I'm going to multiply by the reciprocal and get 2v over 1 minus v squared dv on the left-hand side. Now I integrate both sides, and when I do that, the integral of 2v over 1 minus v squared, I use u substitution. So I'm going to let u equal 1 minus v squared, then du is negative 2v dv. So notice I have a 2v dv, so the negative gets pulled outside, and it becomes negative 1 over u dv equals negative natural log of u. And finally what I can do is I can resubstitute, and I can say negative natural log of 1 minus v squared is equal to natural log of x plus a constant. Now I'm going to resubstitute. Remember, y was vx, so v is y over x. So where I see a v, I put a y over x, and I get now negative natural log of 1 minus y over x quantity squared equals natural log of x plus c1. So now I multiply left and right by negative 1. If I multiply a constant by negative 1, it's still a constant. Let's just call it c2 for now. And then the negative sign can get pulled up using the rules of logs with the natural log of x to the negative 1, and then still plus c2. So the next step is to realize that we have logs of both sides, so we could take an exponential of both sides. The exponential cancels this log. Notice with this one, though, it's e to the ln of x to the negative 1 plus c2. I can break that up as a product. E to the c2 I'm going to call c, and then e to the natural log of x to the negative 1. The e and natural log cancel, and I just get x to the negative 1. Okay, finally, and this is a little assumption I'm going to make. I'm going to assume that all my expressions are positive here. If they're not, you deal with them in cases. But for now, if they're all positive, then we can look at this and get rid of the absolute values. When I do that, I can square this out, and you get y squared over x squared is 1 minus cx to the negative 1. I can multiply by x squared, and then take a square root, and after doing that algebra, I get y is plus or minus the square root of x squared minus cx. And that's my final solution. Y equals plus or minus the square root of x squared minus cx. And we're finished.